Hi, my name is Christian Ramos, and this is my Physics 2 Lab 3 presentation. So, a table of contents, we're going to have our introduction, then the experiment, then we're going to have some data analysis, the code, we're going to have the discussion, and then finally we're going to have the conclusion. So, just to introduce this lab, what is the purpose? The purpose is to gain a visual understanding of magnetic fields and to gain understanding of between the distance and magnitude of a magnetic field. Some of the concepts, the Savart law, we're going to use the magnetic field of a dipole on axis and then magnetic field superposition are all three that we're going to use. Some of the formulas, we have the magnetic field equation, the magnetic field on a dipole on axis equation, natural log of a magnetic field, and the Savart law as well. And then we're going to have our results right here at the bottom. So mu is equal to 22.895 amperes times meters squared, and then n is negative 1.8387. So here's our experiment. So the way we did this, we had the phone and we placed it a certain distance away from the magnet. So that's what the R values are. So 20 centimeters, 70 centimeters, 120 centimeters, 170 centimeters, and 270 centimeters. Then we measured the distance there, and then we measured the magnetic field in Teslas, and then we took those averages, as you can see in the blue on the bottom, and took the natural logs of both of those, natural log of the distance, and then the natural log of the magnetic field, and we get this graph right over here on the right. So you can see as the natural log of the distance gets further from zero, so it starts at around negative 8.42 and ends at negative 10.82. As it gets further from zero, further negative, the natural log of the magnetic field gets closer to zero, which is natural because the magnetic field is going to be weaker further away from the magnet compared to like when it's really close to the magnet. That's when it's going to be a lot stronger. Does that make sense? And then we had more calculations on the bottom with our off-axis field as well. So here are calculations we wanted to find from mu. So we set the magnitude equation equal to the magnitude on axis equation. So that's k times r to the n times mu naught over 4 pi times 2 mu over r cubed, and then we solve for mu, and that's going to be k times r to the n plus 3 times 1 times 10 to the 7, which is equal to mu naught over 4 pi, all divided by 2. So we plug in for k, we find k, and we plug in n, and then we find that our equation for mu is equal to 22.895 amperes times meters squared. So as you can see right here is our code, as you can see surrounding the glow script actually when it ran. So when it actually runs, we find that our distance, is equal to 0.424, and then our our magnetic field at a 45 degree angle at distance d is equal to 1.499 times 10 to the negative 5, 4.497 times 10 to the negative 5, and then 0 in the z direction. And then the magnitude of B at 45 degrees at distance d is 4.74026 times 10 to the negative 5. So which of these statements describes what we observed? When the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. Yes, that's true. As the magnetometer moves closer to the magnet, the measured x component of the magnetic field decreases. It's not true. The position of the magnetometer has no effect on the measured x component of the magnetic field. No. And as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. Yes. Conclusion: what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to the Earth's magnetic field? How would your results have changed? Our results would have been thrown off due to the interference from the Earth's magnetic field. Since we took account for magnetic north, this was not the case, and the x component of the magnetic field was 0. Then what if you were to stick two identical magnets together end to end and run the experiment again? How would our results differ? We would have the exact same vector direction results with larger magnitude. This is essentially making the same experiment with a stronger magnet because the two bar magnets will combine to make one big magnet. So our magnetic dipole would have increased by some scalar.